This question belongs to engineering mathematics subject and the topic name is propositional logic. It was basically asked in GATE 1991. So the question states, choose the correct alternatives, more than one may be correct and write the corresponding letters only. If F1, F2 and F3 are propositional formulae such that F1 and F2 implies F3 and F1 and F2 implies negation of F3 are both tautologies, then which of the following are true? Both F1 and F2 are tautologies. The conjunction of F1 and F2 is not satisfiable. Neither is tautologous, neither is satisfiable, and none of the above. So let me tell you first some of the basic statements. What is a tautology? Tautology is a condition which is always true. Always true. For any value. And what is a contradiction? Contradiction is a value which is always false. And we can also write contradiction to be not satisfiable. Satisfiable. Okay. Now the third one we have contingency. Contingency is a value which can be true or can be false. Which means it is a mixture of true and false. So this is contingency, this is contradiction, and this is a tautology. Now focus on one thing, that here F1, F2 and F3 are propositional formulae. So what is a propositional variable and propositional formulae? Propositional variable. What is a propositional variable? It can have atomic value, which means either true or false. Like when we write P or Q or R, then these are propositional variable. And what is a propositional formula? It is a combination of one or more propositional variable connected by some symbols. Like P is also a propositional variable. Negation of P implies Q, P and Q. All these are propositional formulae. They have atomic values. Propositional variables have atomic values, and their values depend on propositional variable. Okay. Now let us see what this question is saying. So the question says they are propositional variables. Now let me tell you one more thing. What is P implies Q? It is equivalent to negation of P plus Q, or we can write negation of P or Q. Okay. Now it is saying F1 and F2 implies F3 is a tautology, which means F1, we have F1, we have F2, and then we have F1 and F2 implies F3. And then we have another term, F1 and F2 implies negation of F3. They are tautologies. Now we can have various propositional variables, like we can have 3, 4, 5 propositional variables on which this F1 and F2 is defined. So we will have truth table like this. We will have various fields in the truth table depending on these values. If we have n values, then we will have 2 to the power n field in the table. Now they can have various values. The two variables can either be true true, true false, false true, or false false. They can just have these 4 values, and we will have various 2 to the power n values over here. Okay. Now let us see what is the meaning of F1 and F2 implies F3 is a tautology. If we expand this according to this, then we will get negation of F1 and F2 or F3 is a tautology. Tautology means always true for any value. Let us expand it further. So we will get negation. So what is negation of P and Q? It is equivalent to negation of P or negation of Q. So it means negation of F1 or negation of F2 or F3 is always true. Okay. Now let me expand this term, the second one. If this is tautology, then it means negation of f1 and f2 or negation of f3 the tautology. And if we expand this, then we get negation of f1 or negation of f2 or negation of f3 is a tautology. Now focus. Here we have two terms. This term is common in both. Okay. And here we have or of negation or f3 or negation of f3. So suppose we have terms like, if we can say P or Q is true and P or negation of Q is true, then what it means? It means that whatever with the value of Q can have any value. As here, if Q is true, then here it will be false, and if Q is false, then here it will be true. Which means what Q will have both values, but for both of them to be true, P should always be true. Which means P should always be true. Okay. So here what this means? This means that F1, which means the first term, negation of F1 or negation of F2 should always be true. Always true. It should always be true. Now let us see what are the values of. Now let us draw the truth table for this negation of F1 or negation of F2. Okay, so I will draw the truth table over here. Okay. We have F1, we have F2, then we have negation of F1 or negation of F2. Okay. We can have values like true, 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 false, false, true, or false, false. So what is negation of true? It's false. False or false? It's false. Negation of true is false. Negation of false is true. So it's true, and it's true. And here we arrive to the conclusion that this should always be true, which means this condition shouldn't occur. This condition shouldn't occur, and all these are acceptable situations. So let us see the options now. Both F1 and F2 are tautologies. No. If both are tautology, then we will get false and this condition shouldn't occur. So A is false. The conjunction F1 and F2 is non-satisfiable. Now let us find the value of F1 and F2 for these three conditions. It's false, and it's false. It's false means it is contradiction, and contradiction is also called non-satisfiable, which means option B is true. Neither is tautologous. No, it's false. As we can have F1 or F2 can be tautologous if the other one is false. Option C is false. Neither is satisfiable. Tautology means satisfiable. No, this is also false, as we can have satisfiability can be there. This is false. Option E is false. So answer is option B. So let me brief it up. What we have done, we have found out that both are tautologies, so we have expanded them. When we expanded that, then we came to know that F1 do not depend, as here it will be true, here it will be false. Thus the first part should always be true. For first part to be true, both of them can't be true, so both of them can't be tautology, and we found out that F1 and F2 is a non-satisfiable or it is a contradiction. So answer is option B.